I hope you are fine and in best of your health at the moment. So today we are going to solve two very important integrals. The first one being e power ax sin bx, and the second one is similar, just in place of sin I have cos. So how to solve these two types of integrals? We solve it using integration by parts. So let's solve this one by one. So I am solving the first integral first. So what I will do, that I will let this first integral as I. So I will be my integral of e power ax sin bx. Now according to Eilert, what Eilert says that the which function will come first, that will be trigonometry, because ILATE exponential is last, t comes before. So this will be my first function, this will be my second function. I will integrate this. So let's proceed. You know the formula of integration by part, that is first function as it is. So sin bx will remain as it is. Integration of second function. So integration of e power ax minus integral of derivative of first function. So derivative of sin is cos. So cos bx divided by what is the coefficient of x, into integration of second function. So again integral of e power ax and this whole integration. Fine. So your I is sin bx, integration of e power x is nothing but e power ax divided by whatever the coefficient of x is, minus integral of, now this cos bx by b as it is, integration of e power x, again same, e power x by a, this whole integration. Now I will one thing I did incorrectly, and that was while doing differentiation I write these terms in numerator, and while integrating I write the terms in integration in denominator, while differentiation in numerator. So differentiation of sin bx is cos bx multiplied by b. Here again it will be cos bx multiplied by b. Okay, so I can take this b and this a in denominator outside. So this will become I equals to sin bx into e power ax by a okay, minus, and take b out, take a out, so minus b by a. What you are left inside is cos bx and e power x. Now again I have to use integration by part, because again I have got the product of two functions. So similar, take this as the first function, take this as the second function. So your I will be equal to sin bx e power ax by a, this is solved, so write this as it is, minus b by a. Again you do integration by parts. So first function as it is, Integration of e power x is e power ax divided by a minus integration of derivative of first function. So derivative of cos is minus sign, so I'm changing this minus sign to plus, so it will be sine bx, and with the help of chain rule an extra b will be multiplied. In differentiation it is multiplied into integration of e power x, so again that will be e power x divided by, and this whole integration. So I equals to sine bx e power ax. Normally we write this e power x in front in order to avoid confusion, so that it doesn't look in the angle of sine, so argument of sine, so we write like this: a e power x sine bx divided by a minus b by a. Now look at this sine, if I take b by a out again, so let's write this as it is: cos bx e power ax by a, and from this integral if I take b by a out, I am left inside as e power ax sine bx now. If you look at this carefully, let me show this. This complete integral, if you see, then this integral is the same as what we have assumed as I e power x sine bx. So I can rewrite this as I. Okay, so if I rewrite this as I, so I will get I equals to e power ax sine bx divided by a minus this b by a and this complete thing is your I. Now I want to take this I term to the LHS so that I can just rearrange this and find the value of I. So if I take that, so minus b by a into b by a, b square by a square with a negative sign multiplied by a. So if I take that to the LHS, let's move to the next page. So in LHS I will get I minus b square by a square I from the right hand side, so that will become plus b square by a square I. RHS remains as it is with e power ax sine bx by a. And here I have minus b by a square e power ax cos bx. Let's rearrange this. In LHS I can take I common, I will get 1 plus b square by a square. This will become, if I take e power ax common, so this is a times sine bx minus b times cos bx divided by a square. So I am writing that here. If I take this 1 plus b square by a, sorry, a square was there. Okay, so a square is here. Okay. So if I take this term again to the right, just by cross multiply, so I will get I equals to, this term is nothing but a square plus b square divided by a square. So if that will go to the RHS, that can now be written as a square divided by a square plus b square. This is e power ax divided by a square, and inside bracket I have a sin bx minus b cos bx. So this a square gets cancelled. This is what we wanted and we got it perfect. Okay, so again important integral. Now we will see how we can memorize this also, because every time you don't have the time to just learn this, derive this in a competitive examination or MCQ type problem. You have to sometime use it directly, use the concept directly. So in that case, how to use this directly, that also I will tell. So let's move to the first page again. We have this two integral. I will derive the second one also, although it is always a better practice to solve the second one yourself, because you already know how to solve. These two are similar, but then also I will come to that. First let's see how to memorize this. So e power x divided by a square plus b square will come in both the integrals. In the first one and in the second one, see what is here, sin bx is there. So always write a in the starting, because sin bx is there, write sin bx. Because cos bx is here, so write cos bx. Now because sin is here, write minus. Because cos is there, write plus. Okay. Now what is left now? We have already utilized a, so b is left, and we have not written cos yet, so cos bx. Complete. Now again, sin is left and b is also left, so b sin bx. That's simple. You can learn it like this, that sin is an odd function, so minus sign comes. Cos in an even function, so plus sign comes outside, and a will come in the starting, b will come in the with the second term. Minus plus, you all know, e power x divided by a square plus b square will come with both the terms. So it's easy to memorize. So let's jump into the second derivation, which is of e power x cos bx. So it is so the second one I am also again taking as I. So I is e power ax cos bx. According to the idea of islet, as you all know, this is the first function, this is the second function. First function as it is, Integration of e power x is e power x divided by a minus integration of derivative of first function. So derivative of cos is minus sine, so minus minus plus sin bx, and with chain rule b will come in front, into integration of e power x, so that is e power x by a, and this whole integration. Again I will take this b by a out, so I will be e power ax cos bx by a plus b by a sin. Now we will have to use by part again because this doesn't matches with I, so we cannot let this as I. So this is the first function, this is the second function. Let's use by part again. So I equals to first function as it is, integration of e power x, everyone know e power x by minus integration of derivative of sine is cos, 1b will come because we are differentiating, into integration of e power x is e power x divided by a, whole integration. Again if I take this b by a outside, what I will get? I will get I equals to e power ax cos bx divided by a plus b by a sin bx e power ax by a. Now if I take b by a outside, inside I will get e power ax cos bx. As you can see, this is nothing but this one, e power x cos bx dx is nothing but your I. Okay, so because this is your I, you can replace this by I. Okay, so in the next step, I is e power x cos bx by a and we have b by a, you can write this as b by a square sin b by a square e power x sin bx. And minus b by a times I. Okay, one thing you did incorrect, because this b by a will also be multiplied with this b by a, so this will become minus b square by a square times I. So minus b square by a square times I. Now I will take this term to the LHS now. So I plus b square by a square times I will be equal to, in RHS take LCM, so a square will come, here you will get a if you take e power ax common, so inside you will get a cos bx and plus b sin bx. Now again, if you take I common, you will get 1 plus b square by a square now. This is a square plus b square divided by a square. Send this to the RHS. So I will be equal to a square plus b square. Sorry, this will flip. So a square divided by a square plus b square into e power ax divided by a square, and you are getting a cos bx plus b sin bx. So this gets cancelled. You are getting your dream solution, which is I equals to e power ax divided by a square plus b square, a cos bx plus b sin bx. Okay, so it was to come like this, because as per the trick, e power ax divided by a square plus b square will always come first. A will come, and with that what was in the integral, e power x cos bx, so cos bx will come, because cos bx is an even function. This is just for remembering. So even function, so plus will come. What was left? B was left and sin bx was left, so that will come. Okay, so that's it for this two integrals. In-depth study was there, but at the end of the day, if it's an MCQ type problem, you just have to apply this formula, get to the answer as quick as possible. And in case it's a subjective type problem, then you have to derive. Then also you know how to do. Apply integration by part once, twice, then you will get to your final solution. That's it from my side. For more such videos, subscribe to this channel. Thanks and have a nice day.